Good evening all. You're welcome to Tutorials with Fermenting the Schoolboy. Today we take a look at physics. We are still treating the topic measurements and the units. And under the topics, we have different subtopics. We have length, area, and volume. We have mass. We have time. We have fundamental physical quantities, derived physical quantities and their units, dimensions, limitations of experimental measurements, position, distance, and displacement. Actually, when we are combining both WAEC and JAMB class, O-level and entrance exam classes, we treated some of these things before we separated it. So there's no need going back to them again. So the one we've treated derived quantities and their what? Units, fundamental quantities. We've treated dimensions, right? Hope I'm correct. So then errors. This talks about the errors. The errors. We have somehow talked about them. We are still talking about length, area, and volume. Specifically, we are in what? Length. If you can remember, we are in what? Length. So after length, we go to area and volume. Then before we go to mass, then time, and the last topic under this is measurement, position, and distance, and what? Displacement. So let's look at length. We've talked about we've discussed so much in length. I think we just finished how to use vernier calipers to measure length. We are in a class. You didn't go to class that day. We described vernier calipers, how to read vernier calipers, and you also not in class that day. But we cannot continue going back. We should move forward. Today, we move over to how to measure length, how to read micrometer screw gauge. That's what we do today. Micrometer screw gauge. As we discussed in vernier calipers, that are used to measure small length, right? But these micrometer screw gauge are further used to measure smaller lengths than what vernier calipers can do what? Measure. Like now, look at this paper. Are you aware that we can measure the thickness of this paper? I can tell you, if I get a micrometer screw gauge, I can tell you what millimeter or 1 centimeter is the thickness of this paper. You know thickness. You know what I mean by thickness, right? Who doesn't know what I mean by thickness? Please, if you don't know, please let me know. Please don't keep quiet. Thickness is this. This is the thickness of the paper. Now, we have a thick back notebook, thick back. That's what they call it, thick back. The back is thick, right? You can measure the length. This paper now, you can measure the thickness. It's also a measure of what? Length. Thickness is also a measure of what? Length. So you can use micrometer screw gauge to measure this. Who has seen a simple pendulum before? Who has seen a simple pendulum? Touched it. Pendulum. Chewe, have you seen a simple pendulum before? Have you seen it before? Come on, you see when you go back to school. You see that. I think you start. So you have not done physics practical before? Practical. So have you done simple harmonic motion using simple pendulum? Where you tie a small ball to stand and do like this. I'm checking time. Have you done it before in your physics lab? the time at which it moves like this. That small bulb, that metallic bulb is that is what is called simple pendulum now. That small bulb you tie with a rope. That small bulb you tie with a rope, a thread or something. That is simple pendulum. Okay? Good. Now, you can measure the diameter. Micrometer screw gauge, they are used for accurate measurement, like measurement of diameter of a wire. Like measurement of diameter of a wire, the diameter of a simple pendulum. It's a small ball, example, a small ball, example, simple pendulum. Or even the thickness of a piece of paper. The thickness of a piece of paper. The thickness of a piece of paper. So you can use micrometer screw gauge to measure the diameter of a wire, thickness of a piece of paper, and the diameter of small ball. Example, simple pendulum. I'm making point now. You're not writing anything. What is the problem? I made important point now. You didn't. Don't you like writing? Huh? Put it down now. While lecture is going on, we're putting down something. That is how to follow up in lectures. Huh? Okay. Let me repeat myself again. I said that micrometer screw gauge is used for accurate measurements, like diameter of a wire, diameter of a small ball, example, simple pendulum bulb, or thickness of a piece of paper. Who can remind us the accuracy of vernier caliper? Who can remind us the accuracy of vernier caliper? 0.1 what? Vernier caliper. You are talking about meter rule. 0. what? 0.01. Meter rule, the accuracy of meter rule is 0.1 cm. The vernier caliper is 0.01 cm. But that of micrometer screw gauge is 0.001 cm. We have instruments, accuracy. Under accuracy, you have it in meter, centimeter, and in what? Millimeter. Meter rule, the accuracy is what? 0.1 cm. In millimeter is what? 1 what? Millimeter. Vernier calipers is 0.01 cm. In millimeter is 0.1 millimeter. Micrometer screw gauge is 0.001 cm, while in millimeter is 0.01 millimeter. Please note this point. So, note this point. It's very, very important you note this point. Okay? This is the accuracy of these instruments. These are the accuracy of this instrument for what? Lengths. Hope you know that by accuracy, we mean least possible what? Error. Hello? Least what? Possible what? Error. This also talks about least possible what? Least what? Least what? Possible error. That can occur if you are using the instrument directly. Okay? It talks about the least possible error if you are using the instrument directly. Okay, let's continue. Now, you know, when we describe the vernier calipers, we said that the vernier caliper has two scales, right? Main scale and what? Vernier scale. Micrometer screw gauge also has what? Main scale and what? Vernier scale. Let me draw a sketch, have a sketch of what micrometer screw gauge looks like. Okay, look at this diagram on the board. This is a diagram of micrometer screw gauge. Now, as I said before now, as we have in the vernier caliper, we also have the main scale. This is the main scale, and this is the what? Vernier scale. Hello, are we together? We have main scale and what? Vernier scale. Now, another thing I want you to note here is that there's what is called anvil and spindle. We have anvil here, we have spindle here. This anvil and spindle are the jaws. Is you stand up, you are sleeping, stand up. Stand up so you can follow the class, okay? So, the anvil and the spindle, they are the jaws that hold the object you want to do what? Measure. Now, this is the object. The object here now, as you can see in the diagram, is a pendulum ball. You see this spherical object here. As you can see, the spindle and anvil, they are holding it together. The two of them are holding the what? The object. Now, if you put it and hold the object, you can now take the measurements, both on the main scale and the what? Vernier scale. Now, what I want you to know is this. If there's no object here at all, that means the spindle and anvil will come together, true or false? Because if there's no object here to measure, they come together. That means the reading here should be what? 0. True or false? The reading should be what? 0. When there is no object here. Now, if you want to put the object, you now adjust here, like this, turn it like this, so that this will go back and create a space where the object can do what? Be fixed. Now, as you move it, as you turn it now, as you turn it now, the vernier scale will move, will slide. As the vernier scale is, as you turn this handle now, the vernier scale will we have what is called a rotation will be made. If a complete rotation is made, as you turn the ratchet, this is ratchet, and this is the thimble. As you move it, this thing will move like this, It's moving like this. As you roll it like this, it's moving what? Like this, and is making a movement on the what? On the what? Main scale. Now, as you turn it make a move on the what? Main scale. You now put the what is it called? The ball or whatever you want to measure, and tight it so that it will fix the thing. You can now take the reading. This will stop at a point. It will stop at a point here. You take the reading at the what? Main scale and the what? Vernier scale. That is how to take a measurement using what? Micrometer screw gauge. But now let's go down to the accuracy. How did we come up with this accuracy of 0.001 cm? Now, remember I told that this accuracy talks about what? Least possible error. It's also talking about what? About what? The minimum graduation. Hello? The minimum what? Graduation. Now, look at this now. Look at this. The vernier scale of a micrometer screw gauge has 50 divisions. Are we together? The vernier scale of a micrometer screw gauge has 50 divisions. Yeah. Look at these things you are seeing here. 20. Look at it. Look up. This you are seeing here. 20, 25, 30, 35. If you turn the other side, 45, 50, 45, 50. It has 50 what? Divisions. The vernier scale of a micrometer screw gauge has 50 divisions. Now remember I told you that if you turn this place, it will roll, it will turn like this, right? Now, if it turns from 0 to 50 division, there is one complete what? Rotation. If it turns from 0 to 50, that means if you have a complete rotation is how many divisions? How many divisions? 59. I told you that you turn like this, right? That the vernier scale has 50 divisions. A complete rotation is what? 50 divisions. Now that complete rotation you did, that complete rotation you do on the vernier scale, we have an effect on the main scale. It will read as a distance of 0.5 cm on the main scale. If you rotate this thing, if you move this thing now to 50 divisions, complete 50 divisions, it will make a move. It will read on the main scale as what? 0.5 cm. Does it make sense? Look at it now. If you turn this now to have a complete 50 sit-up. If you turn this now to a full rotation, a full rotation is how many divisions? 50. It will read here on the main scale as what? 0.5 cm. Are you with me? I want to tell you how we come up with the accuracy. Remember, I said that accuracy is the least possible error. At the same time, the minimum calibration, the minimum graduation. Remember I said that. That is the one graduation. Do you know why we say that accuracy of meter rule is 0.1 cm? Because that small graduation, one of it is what? 0.1 cm. It's not true. It's the same thing with vernier caliper. Why we say that is 0.01? Because if you go to the vernier scale, the smallest in the vernier scale is what? 0.01 cm. Now let's determine that of what? Micrometer screw gauge. I see that 50 division in micrometer screw gauge, if you turn full rotation, which is 50 division, it will give on the main scale, it will give 0.5 cm. So if 50 division, do the calculation yourself. If 50 division gives 0.5 cm, one division will give how many cm? Do the calculation yourself and tell me. If 50 divisions on this vernier scale for a micrometer screw gauge gives 0.5 cm on the main scale. Now, one division at the vernier scale will give how many cm on the vernier scale, on the main scale? Huh?
0.01.
It's not true.
Like if it is 0.1 cm.
0.1, is that what I said?
0.5 cm.
Then
one division will be 1. Because multiply.
0.1 cm. What are you saying?
You say that if 50 division gives 0.5 cm, then one division will give 1.
You got what?
0.01.
0. What?
0.1.
Okay. Zero. What did I say? Sorry. Wait. There's a point I missed here. There's a very important point I missed here. Please put it down. Put this in down, please. Put this in down. There's a very important point I missed there. Put this in down. Are we ready? Huh? When you take the, what is it called? On the main scale of the micrometer screw gauge, the distance there is graduated in watts. The main scale is graduated in what? Millimeter. Please put it down. I put it there under the main scale. Please. The main scale is graduated in millimeter, not in centimeter. Please. The main scale is graduated in what? I made a mistake. That's why I came and started saying 0.5 cm. It should be what? 0.5 what? Thank you. Please note that one down, please. That's a mistake for me. On the main scale of the micrometer screw gauge is graduated in what? Millimeter. So this will help us to calculate how many millimeter one division here will give us. Okay? So if 50 divisions on this vernier scale, if 50 divisions on the vernier scale gives what? 0.5 what? Millimeter on the main scale. Therefore, one division on the vernier scale will give x. X is now equal to what? One division times 0.5 millimeter all over what? 50 division. Division without division. So we have 0.5 millimeter over what? 50, which is what? 0.01 what? Millimeter. See it here. 0.01 what? Millimeter. So on the vernier scale, one division on the vernier scale is how many millimeter? 0.01 millimeter, which is set as what? How many centimeter? Divided by 10.
How many centimeter? 0.01.
Convert 0.01 millimeter to centimeter, to centimeter. Convert 0.01 millimeter to centimeter. Good. 0. He said as what? 0. Is you guys following us? He said as what? 0.001 centimeter. So one division of the vernier scale of a micrometer screw gauge is what? 0.01 millimeter or 0.001 centimeter. And because this is the lowest, the minimum graduation, that becomes the accuracy of the what? Micrometer screw gauge. Does it make sense? And the least possible error you can commit there is 0.001 centimeter or 0.01 what? Millimeter. So we see the meaning. See the meaning. What it means is this. If you want to take a measurement now and put something here, put something in between the anvil and the spindle, and roll this thing back to fix it, you first take this measurement, okay? Remember, here is in what? Millimeter. True of us. You take this measurement. Then whatever, at any point that this concerned with this place, any place that align with this place, at any point on this where it align with this, it coincides with this line, you take the measurement there. If it is at 30, you know that it's at 30th what? 30 what? Division. So if you want to know how many millimeter are 30 division, what will you do? You multiply by what? Good. You multiply if it has 30. If it is at 30 division, so how many millimeter is measured in the vernier scale? If one division is 0.01 millimeter and it coincides at 30, that 30 is now how many millimeter? 0.3 what? Millimeter. You add it to what you got in what? in the main scale. That will give you the reading on the what of the what micrometer screw gauge. The same thing we did in our vernier caliper now. You add it, you get the vernier scale, add it to the what reading on the main scale. You get your what the reading on your micrometer screw gauge. I will give example now so that you can read it for me. Let's see whether you truly understood what I explained. Okay, look at the diagram above. From this diagram now, tell me the reading on this micrometer screw gauge. Who can answer the question very fast without even thinking? Just look at it and tell me the reading.
15.
Huh?
15.
15? I said, what is the reading?
Okay, the reading.
Uh-huh. From what I explained here so far, who can tell me the reading on this micrometer screw gauge? Fast. Who has finished? 0.65. 0.65. 0.65 what? Okay. Who else? 0. What? 20. Aizu. What's the answer? Huh? Huh? You say what? Tell me your answer now. I think just tell me what the answer is. Do it and tell me what the answer is. Fast. You say what? 0.19. So I have to change it. Okay. .19. Okay. Izu, what's the answer? 0.16. Okay, let's work on this together, please, sir. I want your attention on this thing. Hope you can see the board clearly. Please, the micrometer screw gauge and vernier calipers, they follow the same principle. The only difference is the number of subdivision in the what? In the vernier scale of micrometer screw gauge. Are we together? That's the major difference between them. Now, the same way you read the main scale, keep it, read the vernier scale, keep it, and add the two of them the same way. So, but remember, and also another difference is that this one is clearly stated that the main scale of micrometer screw gauge is in what? Is graduated in what? Millimeter. Is clearly stated. Now look at this. Look at this now. Who can tell me what is the reading on this main scale? Huh? You don't know? You don't know? This is where your issue came from. Now listen, please. The first thing they gave sent here is what? 0 millimeter. 0 what? Millimeters. So because it's 0 millimeter, you don't need to be told that here it should be what? 1 millimeter, 2 millimeter, 3 millimeter, and what? 4 what? Millimeter. Are we together? Since here is 0 millimeter, you don't need to be told. It's not everything. It's not all the questions they will give you from this to this. Some they will just, now this one now is somehow. This is jump questions. They don't give, they just wrote only 0 millimeter. It's you that it's there for you to know that this is 0 millimeter, followed by what? 1 millimeter, 2 millimeter, 3 millimeter, and what? 4 what? Millimeter. So the main scale is how many millimeter? 4 millimeter. So what is vernier scale? Vernier scale is what? 15 what? What is vernier scale? How many millimeter is it? It should look for it in millimeter now. 0 point what? Are you sure? So you add it to this one plus what? 0.15 millimeter. So the answer is what? 4.15 what? Millimeter. Now let me ask you a question here now. From this diagram we drew here now, here is about 7 millimeter. From this diagram now, tell me the reading on this thing now. 7 millimeter. Why not get close and see what you are? Go there and see it well on the board. Huh? 21 point. .30 millimeter. And who else? Who else? What do you get? Let me see what you got.
Sorry, I'm not solving it.
Why? Seven point what?
So the second one I could ask you.
Are you asking me? Go there and check it. Check where they consign.
I think it's 7.32.
7.32. What's your own?
7.2 by 3.
253. What? Millimeter. Hey, hey, hey. Hey, hey, hey. 7 point what? Okay. And let's see now. What is the reading on the main scale? It's not. Here is 7 millimeter. If remember this here and here look alike, right? This one go up, right? So this should be what? 8. True of us. This one should be what? 9. So on the main scale we have what? 9 millimeter. So just match. Look for where they look. The measure, the calibration is almost equal. It's equal. You start counting. So here now if you look at this place to check the vernier scale, where do they coincide? Look at. 3 of you should come close. Come close. Come close. Look at this vernier scale. This thing coincide at this point. Do you agree with me? If you trace it now, it coincides here. Here is 25. Here is 26. Here is 27. Here is 28. True of us. So this is 28 what? Divisions. So how many millimeter is 28 divisions? 0. What? 0.28. 0.28 what? Millimeter. So the reading on the vernier scale is what? 0.28 millimeter. And the reading on the main scale is what? 9 millimeter. So the reading of this micrometer screw gauge is what? 9 millimeter plus 0.28 millimeter, which is what? 9.28 what? Millimeter. So I don't know where you got this from, but you've seen the correction, right? Please try as much as possible to, look for more questions on this and try them. Okay, let me draw this one and see whether you can get it. Now, I think after this one, we'll stop here for today. Okay, look at this one I want to draw now. That. Then where? Come and point at. Let me see what. Anything you cannot see, please go to the board and look at it very well. This is 5. So what's the answer? The first one is 0, followed by 5. So what's the answer? Any other person? Check that thing very well. That is not 5.25. Check it well. Before you can answer the question, study the graduation very well. Before you don't just answer anything you see on the diagram. Study the graduation very well. Study the graduation very well. Try to understand how it is graduated. Or how they presented it before you can answer the question. It must not come in the same form. Have you seen a mistake? Huh? You won't see a mistake. Okay. So you put 3 away the two graduation after that 5. And got what?
5.65.
One of these graduation is how many millimeter? First of all, ask yourself a question. One graduation there is how many millimeter? One graduation there in the main scale is how many millimeter? In the main scale. What are you saying? In the main scale. I thought you people understood this, but the answer you are giving me now. Sit up, please sit up. That is not how to study. Be doing something, people are not doing it. It's also he's the only one trying to calculate this thing. People are staying as if you are tired or what? What is the graduation on this? One graduation is how many millimeter? From this thing here now, one graduation is how many millimeter? That is the first thing to resolve first. If you cannot resolve it, then just one graduation, 0.02. What are you even saying? What? I'm confused. I'm surprised. You three of you should stand up and go to that board. Go to the board and look at that very well. What are you even doing here? The first calculation there is what? The next one is what? So in between 0 and 5, what are there? Head to one graduation is what? One what? Well, I count that thing very, very well. What is the reading on the main scale? 7 what? Chingo, what is reading in the main scale? Chingo, the first graduate is what? Followed by what? 4. Point that 4. Let me see the 4. I don't know. What is follow? What is after that 0? What is that?
5.
Where is the 5? Now, what is in between that 0 and 5? How many divisions are in between that 0 and 5? So, what should be the next one? What I teach people about something like that? If that place is 5, what should follow that 0 immediately? Don't stand there and hold your hand. Be counting it by yourself and tell me what you follow. What that is 0. Count it there now. And what? Continue. What's wrong with you? What is your problem now? Now, what is the nature of your problem now? What color is your problem that you cannot think? You are giving 0 to 5. You don't know the common sense will dictate that you should count and know what one division should be. So one division there is how many millimeter? I'm asking you fast. One division there is how many millimeter on the main scale? Do you even understand what a division is? Eh? On the main scale, is that in your pot? Is that the main scale? Uh-huh. A division there is what? A division there is how many millimeter? What is a division? So I'm here wasting my time talking division. You didn't understand and you kept quiet. You didn't ask me, sir. I don't know what a division is. Are you ashamed of to ask me to know what? What is a division? What comes to your mind whenever I hear division? Answer me. Don't keep quiet there. Be looking at that thing and pointing it. What's the division there? Huh? Leave that place. You go there. Leave that place. Uh-huh. What's point the division there for me? Uh-huh. Good. A division is how many millimeter? 5 millimeter. Uh-huh. Then how many divisions are on the main scale? So then how come? How many divisions are there? 7 divisions. So how come the division becomes how come the total reading is 7 millimeter, where one division is 5 millimeter? What are you even saying? A division there is how many millimeter? Huh? God. Wow. Shift. You go there. Oh yeah. Point division, let me see. Point division, point let me see. I count the divisions there. How many divisions are there? Then a division is how many millimeter? How did you get one? If you look at me again now, I will do it with you. Look at the board. You see me you're looking at. You got that place. Shift there. Look at the board, not me, and learn. I mean, for the past 2 hours talking about the same thing. Continue. Good. So how many millimeters are there now? 7. So what is the reading on the main scale? Shift. Go there. So what did she say now? What did she say now? I ask you a question. What did she say? How? Explain how is 7 millimeter. How is 1 millimeter? I want to know someone to tell me how you got that 1 millimeter, because question can be changed. That's what I'm trying to make people understand. People don't think. I don't know why. Critical thinking has disappeared among students these days. I don't know what's going on. Things must not be given to you the way it was given to you in class. It's not true. Things can change. Questions can be twisted. It's ability for you to reason. It's just to help you to solve questions. Now, I want you to tell me, how did you get that 1 millimeter? How do you arrive at that 1 millimeter? And I've taught this in this class. Who can tell me how you arrive at that 1 millimeter? If you don't know, shift, please. Shift, if you don't know. Who can tell me how you arrive at that 1 millimeter? Chine, go there, Chine, go there. Tell us how you arrive at 1 millimeter.
This one is 5. Means that between this place now is 1, 2, 3, 4, 5, so 6 and 7. So showing that if you count this calibration here now, then we divide it by total of the calibration, then to give 1 millimeter.
You have the idea, but it's not clear. If I say this for again, I will never say this. Stand well. Put your hand down. That's wrong. Your posture affects your learning. If you don't know it today, your posture affects your learning. You just disappear. You think that you are in class, but you have gone. You are thinking about one nonsense in class. That's the reason why after teaching, you come back, you ask questions, you look at the because you were not there, but you were there physically. I've taught this in this class. Let me do it again. I will not do it again in this class. I will not try it again. Look at this thing. This is 0. And you are giving 0. You are giving 5. This is the only 2 readings you are giving. And this 0, between the 0 and 5, we have small calibration between them. How do you know the value of this small calibration? Simply do 5 minus, for count the calibration. This is already what? 0. So here should be what? 1, 2, 3, 4, 5. So from that 0 to 5, we have 5 divisions. 0 is not true. 1 division, 2 division, 3 division, 4 division, and 5 division. But here is 5 millimeter. Here is 0 millimeter. Simply do 5 millimeter minus what? 0 millimeter is what? Is what? Is what? Is what? 5 millimeter. Divided by what? Number of divisions. You got there. 1 division, 2 division, 3 division, 4 division, 5 division. 5 what? Divisions. 5 divided 5 is what? 1 millimeter. What this means is that one of the calibration there is 1 millimeter. 1 millimeter. So, if here is 0 millimeter, here is what? 1 millimeter, 2 millimeter, 3 millimeter, 4 millimeter and what? 5 millimeter, 6 millimeter and what? 7 millimeter. So the reading on the main scale is what? 7 what? Millimeter. Then what is the reading on the variance scale? 25 what? Division. Then convert it to millimeter. Is what?
0.25.
How do you get 0.25? You multiply by what?
0.01 millimeter.
So you get what? 0.25 what? Millimeter. So you add it to this 7 millimeter. You add 0.25 millimeter to 7. So the reading of this scale is of this screw gauge is what? 7.25 millimeter. Simple. Someone will stand here and be teaching you, you'll be here, but you're not here. And I'm asking you, and I will tell you anything you don't understand, ask question. I get angry when after telling you to ask me, you not ask question. Then if I give you something to solve, no, I don't tolerate such. If you want me to train you, you must be up and do it. I don't do anything with lazy people. You will up and do it, you work hard for it. The answer is what? 7.25. Any question on this? Go and sit down. Go and sit down. Do you have any question on what we did today? Any question on what we did today? Please ask. If you have any question on any area you need some clarification on what we did today, please ask. Today we started with we reviewed the assignment on chemistry, and I believe that there's no question there. Then I hope you copied this assignment on physics. Please ensure you do this assignment on physics. Ensure you do it. Tomorrow, by God's grace, we'll review it. Don't just, as I said before, don't just carry the assignment and start doing it. Try to go through the principle behind each of these topics. Go through your textbooks. Go through the principle behind these questions came from different topics under measurement and units. Ensure you go through the topics before you start doing the assignments. This is what you do this night. Don't go home and pack your book and keep. If you pack a book and keep and go to where I will know whether you just pack your thing and kept. And I will take it lightly on you. Go through your textbooks. Go through these topics. They came from different topics. And they study them critically and answer these questions. Don't just go online and copy one answer, come here and give me. I won't take it easy on you. Then, without about the micrometer school Guage and the accuracy and other things involved, how to read the micrometer school Guage, give examples, and I am not yet completely satisfied with you who post performance on this micrometer school Guage. In our next class, I'll give about 2 or more examples to see whether you have mastered how to read these things. You should master how to read them. Vernier caliper and micrometer school Guage. I'm not satisfied with their performance in them. I'll give you I'll give you more examples to solve in my presence, so that I'll certify you that yes, you have known how to read them. All right. In the absence of any question, I think we'll stop here for today. And please, I beg you, please study. Please study. You must study. So far, you decided that you come under my tutelage. You must learn how to study. It's a must. It's not negotiable. So if you don't be studying, please better start, because if not, you'll be crying here every day. You must study. No time to waste. Don't waste your time. Study. Study. And the joy of it is that if you study and come here, if you actually studied and come here, I will know. Because when questions are asked, the way you answer it, you may not get it correctly. I will always correct you. But I will be impressed that at least you studied it. It's annoying that you go home and pack your book and keep. I don't understand it. Then what takes your time? What takes your time at this age? What distracts you? What other job do you have rather than to study? That's why your parents are paying heavily for you to come for tutorial. Then what else do you do? If you studied and come to class, and if you study what we did, study more and come to class, doing discussion, I will know. At least if you are not getting it, at least I'll correct you. I'll be happy that from the way you answer it will show that you study something. So please, I want you to learn how to study. Did you see how you answer questions on chemistry when we are doing our review chemistry? I was impressed. Because that showed that actually he studied that thing, he learned it. So please, I want to be clapping for each and every one of you like that. If not, if you come again, I will shouting at you until you learn how to study. Because there's no petty here. But if I pet you, I'll just spoil you. You just go home and waste your time and waste your parents' money here. You can never waste your parents' money with me. I won't allow it. In fact, that's why I even came here, even though I was very sick. I had to come because each time I lie down here, I noticed that your money is wasting. That's why I came out, to ensure that I'm not even strong, but I'm struggling because I know what your parents passed through to raise this money. So why will you come here? You not go home and study. It's annoying. I won't take it from you. No, I will not. So, all right, we'll see tomorrow. God bless you.